Also,
where is it?
can we take a class field trip to go see Human Centipede 3?
Does that exist?
It's going to be in existence.
NIO file. It's another NIO.file.
Oh, NIO.file. Okay, I got it. And then what's the name of the class? Files? All right, and the method you said is read bytes?
All.
Read all bytes.
Read all bytes. I wonder if this is, does it specify what kind of file it has to be? Let's look at the file constructor. Because this seems unlikely to me, because I mean it is legal to have the byte 175, and you cannot store 175 inside of a byte array. It's
I wonder if it makes the conversion of negative to
well, it still wouldn't fit, even if it made the conversion. Oh, I get what you're saying. I get what you're saying. That it stores the number, it encodes 178 as a negative number,
Yes.
and then does the math. That's possible. That is possible. I have no idea why they would do that, but it's. I can't imagine encoding it with a negative value would be beneficial. That's weird.
Well, we could at least use the byte to, it's a smaller.
Yeah, but I mean, we don't really gain that much from it now. I mean, in terms of like, because this is a newer class, so we're not really concerned about using bytes instead of ints in the big scheme of things. But I suppose if you're trying to be as efficient as possible from a storage perspective, then this makes sense. But holding a negative, encoding something larger than 128. As a negative number, just so it'll fit in the byte data type, it seems like what you're spending doing the encoding is worse than. Yeah, that's strange. Yeah, I suppose they could read it. Maybe they can take advantage of it. Read it in as an int, then take that int and subtract from it 127, and then will that work? Then multiply it by -1? No, that won't work. We'll have to just subtract from it, force it into a byte, then add to it the difference, and that'll round it around. Seems like an awful lot of work just to save a little bit of space. I guess I don't have a great explanation, but that's all I can think about. I mean, because bytes can't hold that large of a value because we don't have the option in Java to hold unsigned bytes. It would actually be interesting if somebody wanted to experiment with it a little bit, to read in a file and using this guy and look at print out the byte array and see if it's printing out negative numbers or it's all positive. If it's printing out negative numbers, then it's clearly doing the mapping as you're suggesting. If it's only printing out positive numbers, then something else is happening. Then I mean it's fairly unlikely that you're going to have a file that contains a file of any size that contains only bytes that are between 0 and 128. It seems unlikely that would occur. Yeah, but if anybody can give me a real explanation as to why they did this, I'll give you some extra credit. I think it's
Here, the file reader interface.
from Java.io.
Yeah, it also has the method for reading in a buffer in this case. So it have a method read.
Oh, one of these guys.
Yeah.
But you got it from input stream reader, because it actually inherited it from. It looks
Yeah,
like
it is
file
the
reader
reader.
is literally a synonym for input stream reader.
Yeah, it is the reader one.
Okay. So this guy reads in an int.
Okay.
This guy reads in an int.
No, this guy, the output is
Go down
the
more.
offset. It reads into the buffer. Now,
This guy?
yes.
Yeah, so this is the offset off the beginning. So this is a, well, actually, this would be just for reading in text. This reads characters, not bytes.
There's one that reads a byte array. Hang on.
That's right.
And I can go back to reader. Look at a generic reader. Does that have a read? It does, but it's abstract, so that forces you to re-implement it. But this guy's for reading chars.
Mm-hmm.
So it
File
assumes
input stream can read a byte array.
file input stream.
Yeah, leave a file input stream. It'll take the byte array as a parameter. That's where you throw your buffer, your byte array buffer into there.
Right. So my guess is that same argument. You must encode bytes above 128 as negative numbers. My guess is that's, well, I was going to say that's based on primitive stuff that it kind of inherited from C and C++, but the Java NIO doesn't really explain that since that's newer stuff. My startup disk is almost full. Yeah, to be honest, I don't know. I mean, I'm making guesses. So if any of you can come up with a good explanation or find some documentation on it, I'll give you some extra credit. So it's certainly an interesting thing.
Just deleting the one you're taking right now?
No, it's cooking. We're still cooking. Yeah, that's actually really interesting. All right, binary tree. Let's see, 440 client and server. So that's our server code. This is our client code. Okay, and I think where we left off, if I come in here, I can kill the server, restart it here. Here's our share client. Start that. I'm going to share. Pick the file we're going to share. It's locally buffered it. Then when I connect with one of my other clients and I say I'm going to get, it tells me it's ready to receive this. So we were in our client communication protocol dealing with the get file stuff. So we read in the file name as well as the file size. Then we went ahead and we created an array of bytes to store that. So this is a global value inside of client communication protocol. We give it its value here in get. Where's get? in Git file. So here's where we filled up with a bunch of negative ones because we don't technically have any bytes in there. So we're locally storing negative ones as bad bytes, which if we were using a byte array, that breaks. You know, assuming my guess is correct about encoding bytes above 128 as negative numbers. But we're using an integer array to store it, so we should be fine. And then we print out, we're ready to receive. Now, if we remember from last time, our model relies on each client to be a sender and a receiver. And I think somebody was shoving a socket into somebody else's input stream.
There were some eggs.
Input stream, output stream, and eggs, right? All right, so we have a situation like this, but each client has to be capable of both sending and receiving. All right, now I think we have, in our example here, Tim, you have all of the bytes, correct? So chances are Tim is never going to make a request through the server for some of the bytes. But he might be, the server might ask him for some bytes. So we need to create a protocol for a client to request bytes so it can fill up its array, and then we also need a client to be able to receive a request for a byte that it might have. So really what we need is we need each client to have 2 threads. Okay, we're kind of doing this in an inefficient way, and then what we're going to talk about is streams, kind of as a next step. But we're going to need to create some threads associated with every single client. Okay, one of these threads is going to be responsible for listening for a request from the server for a byte. Okay, remember the server's keeping track of who has what bytes. Okay, so one of those threads is going to be the guy who listens on the client side and waits for a request to send out byte 7, for example. The other one is going to be responsible for asking the server for certain bytes. Make sense? So we're going to need 2 separate threads on the client side. One is going to be the guy who tries to fill the local client's array. The other one's going to be the guy who responds to requests from the server for sharing their individual bytes. So we'll go ahead in here, go into our client. And we'll create a, let's call this byte request thread. Good enough. And this guy's going to extends thread. And then I'm also going to create a what should we call the other one? So byte request thread. This is going to be the guy who handles requests for bytes. And then the other one is going to be a file fill thread. Sound reasonable enough? File fill thread. Okay, so this guy will also extends thread. Okay, now something I'm kind of moving, the path I'm kind of moving down here is almost moving towards introducing another new technology to you. How many of you have heard of a technology called Node.js? Okay, anybody know what it is? Okay, well let me kind of preheat you a little bit before we write these things too much. Because we're really talking about the evolution of network computing. So let's do, I want to do it. Let's just call this slide Modern Web Programming. So most of you have heard of Ruby on Rails, right? Have we talked about that at all in here? Okay. Most of you have heard of Ruby on Rails. You might not know what it is, but you've heard that phrase before. You haven't heard that phrase? Well, you're Amish. That's not surprising. Okay, well, just out of curiosity, how many of you have not heard of Ruby on Rails besides Amish? Oh, half of you haven't heard? Okay, well, interesting. Do you read?
We need a history lesson too.
Okay. Well, I mean, it's well, whatever. Here, we'll take a step back. All of you have heard of PHP? Okay, so I'm going to write these in a kind of an interesting way here in a minute. So I'm going to say Ruby on Rails, and then how many of you have heard of Python?
Oh, yeah.
Not
Ruby
this.
on Rails just long form for just straight Ruby.
Ruby's the language. Rails is something else, which is what we're going to talk about. Python, not the snake, but the language.
I know that one.
Okay, so and JavaScript.
Oh.
Heard of this guy? Okay, but what I'm actually going to do is I'm going to call this node.js for right now. Okay, now I'm going to rewrite these guys a little bit. So PHP, we're going to call this guy PHP on Apache. We don't have to rewrite Ruby on Rails because it's already Ruby on Rails. We're going to rewrite Python and say Python on Flask. And we're going to rewrite Node.js as JavaScript on Node. Okay, so these are evolutions of our client-server kind of web setup. We're writing our own server in this case. So we're writing a little custom server for sharing files, but really what a web server is this guy's job is to share local files. Make sense? So we're actually sort of reinventing the wheel. What's okay about that is we have to provide our own protocol, but I'm going to actually teach you a newer networking technology as kind of the upgrade to ours. That's why we're writing a little bit of a, I guess, a ghetto version of it first. But the punchline on these would be this. So PHP, programming language, so based off of C, typically is used for outputting HTML and JavaScript, what web browsers understand, and we've talked about that in here, right? Web browsers understand HTML, JavaScript stuff. All right, so, but PHP typically works with the Apache web server. We've talked about that as well, Apache versus IIS. Okay, so the idea would be installing, maintaining, finding a place to host a web server is not trivial. Right, so here on campus we have an IIS web server in the other room. Do we have Apache running on something too? Bool maybe? All right, but whatever. We have a couple servers. More than likely, at least half of them are behind a firewall. So they do a pretty good job for doing something locally here in the department, but we can't reach that from the other side of the world. Okay, it's blocked. We're behind a firewall with it. So in any case, having a setup that allows you to have your own server somewhere that is aware of a programming language is not trivial to set up. Realistically, if you have a couple of dollars, you can just go on to GoDaddy.com and buy a hosting plan, and then you have Apache with PHP installed, or you have IIS with ASP.NET installed, but that'll cost you $5 a month. If you want to set it up yourself for free, it's not trivial to do that. Okay? So we're going to say that's the problem with that setup. Okay, it's not easy for somebody to just start writing a web application. Okay, that has a server and a client side to it. They have to kind of get their environment created first, and then they can start working. And there's also a learning curve there. So then comes along this idea of Ruby on Rails. Ruby is to PHP, Rails is to Apache. So Rails is actually the web server. But what it lets you do is it's a local install initially, and it allows you to immediately have a running environment. And Ruby knows about Rails directly. You don't have to teach Apache how to read PHP stuff. So PHP is a module that plugs into Apache. These are made by different people. Okay? Ruby on Rails, this is all one technology. The Rails server is already Ruby aware. So if you're a Ruby programmer, you could immediately start writing web stuff, web backend stuff, server-side stuff, using the Ruby programming language. Okay? So this has actually become quite popular. I'm actually fairly surprised that some of you hadn't heard of it. The good news is it's no longer the cool kid. It's still very popular, but it's actually kind of lost its shine. Ruby while it fixes a lot of these problems up here, relies on a very specific directory structure. Okay, so it kind of sets up your environment for you automatically, but then it relies on you kind of knowing exactly where to put every one of your files so they're kind of served correctly. All right, where some of these newer technologies don't have those limitations. Python on Flask is very similar to Ruby on Rails, but probably doesn't really have the directory structure requirement. But realistically, we can call all three of these the same technology. That is, you pick your favorite language, Ruby, Python, or JavaScript, and whichever one of those languages you want to write your code in, Ruby on Rails comes with a web server that knows about Ruby. Python has a web server called Flask that knows about Python, and Node.js is the name of the technology, but it's a server called Node that knows how to interpret JavaScript. Okay? This is the cool kid right now, Node.js. Why do you think this might be the cool kid?
Rolls off the tongue nicely.
Node.js rolls off the tongue nicely, okay.
A lot of people know JavaScript.
Okay, good, decent point. Why else? Take that a little deeper.
Performance, it's better than.
Okay, actually, that's very related to what we're going to talk about in here. Node.js uses something called asynchronous networking streams, which is kind of going to be our upgrade to multi-threading. So we're going to kind of talk about problems with threads. So that's actually also a true statement. Still not the one I'm kind of looking for yet.
People want to learn Java, but learn JavaScript by accident.
Story of my life.
If you are a web programmer and you're writing client-side stuff, you already know JavaScript. Historically, you've been writing your server-side stuff in PHP. Now you can write your client and your server-side in the exact same language. Client-side dynamic stuff is JavaScript that runs in a web browser. Your server-side stuff now also is JavaScript, except it runs in your web server. So it allows you to leverage one language for both client and server-side. Kind of as a reasonable tool from that perspective, right? Become an expert in one thing, and now you can cover both.
So it's cool because more people are dumb and don't know multiple languages.
Well, it's not necessarily even having to know multiple languages. Now you can share libraries across the two, and there's lots of conveniences.
Yeah.
All right, so that's kind of maybe why Node has become popular, as it sort of makes sense. But really, all three of these are equivalent technologies. Python and Node being newer. Really, Python's been around for a while. Flask was introduced so that Python could compete with Ruby on Rails. People were already Python programmers and like, oh, I'm a Python programmer, but I want to write server-side web stuff. Like, okay, so we wrote Flask to allow you to do that. Node.js thing came out as a single package. So we're going to end up looking at Node.js in here from its asynchronous networking perspective, which is kind of a fix for some of the problems with threads that we're going to introduce. Kind of makes sense at a high level? All right, so we're back to but we're doing this with threads initially. Just out of curiosity, why are threads potentially bad? We know all the things that make them good. They give us non-blocking, allows us to do multiple things at once seemingly. They're lightweight compared to processes, less forking obviously, Abe, but right. But the punchline is that you're at least sharing your CPU time with whoever spawned the thread, as opposed to now monopolizing the CPU with a whole bunch of processes. So there's a lot of pluses to threads, but what's a negative to a thread?
It's hard.
It's hard to do what? To make?
No, to manage
Okay. So
shared resources.
all right. So if you have a lot of threads, it's going to start leading to performance issues, because we're now sharing resources, we're sharing CPU time, and especially within a single application, if you have this much CPU time and you're splitting that across 3,000 threads, well, now all of a sudden each thread really doesn't get enough time on the CPU to really do anything. That makes sense? So it can really give you a bottleneck type problem, as well as a memory issue. Every thread, even though we call it lightweight in that it's not as is not as robust of a data structure as a process, every single thread still is a data structure. It still has to keep track of some stuff. And if you start creating thousands of threads just haphazardly, that's going to start taking up a lot of memory. Make sense? Okay, so we really can't have an infinite number of threads. On top of that, sometimes you get threads that aren't busy doing things. So you might have, in our little example here, you might have 500 clients connect. And out of those 500 clients, let's say that 250 of them leave the client running, but walk away, but never actually start the process, as an example. Okay, so now you have 250 threads on the server that are taking up system resources, sharing CPU time, all that stuff, yet they're literally useless and not doing anything. The person on the client side has just left the client running and never actually started sharing or downloading a file. Kind of make sense? Okay, so it's just wasted resources. But we're going to do it that way anyways, because we want to be inefficient so we can appreciate the new way of doing it. Although threads have been the popular way of doing things for a long time. We just have to kind of be concerned about performance. You don't want to create too many threads, so a lot of applications limit the number of threads that you can create, threads of execution. You maybe even have seen this before in the preferences of some application, where it asks you what limit. Sometimes it'll be like auto, but then it might give you a limit on how many threads you can open at once. You know, maybe it's 8 or maybe it's 10, something like that, but it doesn't allow you to just put in 5,000 threads because it basically says it's not worth it. Make sense? So the ones that have auto there might say, well, based on the fact that you have a quad-core processor, you can technically do 4 things at once, and you have X amount of memory, we'll let you open up 12 threads because that's not hurting anybody. Something like that. All right, so we're going to have our byte request thread, and then we have our file fill thread. File fill thread, this guy constantly tries to fill the byte array for the file, for the receiving file. Good enough. Byte request, this guy constantly listens for a request from the server for a certain byte and responds with that byte. Make sense? So this guy here, byte request, right, he's just sitting there and he's waiting by the phone for the server to, well, he already has a socket communication channel opened up with the server. And so he's sitting there waiting for the server to ask him a question. And the server's going to shoot in and say, okay, I need byte 5. The server would not have asked him for byte 5 unless the server knew he had byte 5. That make sense? Remember, on our server side, we're keeping track of that Boolean array of what bytes each of our connected clients has. So the server is going to come to this guy and say, I need byte 5. This guy will receive that request and then spit back byte 5 from his array. Make sense? So both of these guys need to have access to the array of bytes. One of them is trying to fill up that array. The other one is sharing bytes from that array. All right, so both of these guys it's kind of a stupid reason to do an object-oriented thing, but what the heck, we're going to do it. I'm forcing this a little bit. It's probably somewhat of a waste, but it'll be an interesting review. So I'm going to create a we're going to call this guy client helper thread. And we're going to make this guy abstract. Okay, client helper thread is abstract. What does it mean for a class to be abstract?
Can't make an instance of it.
Yeah, we can't make an instance of it. Okay, so I'm going to go ahead and we're going to say that we have a protected int array called we'll call it the file array. And then we're going to have a constructor for this guy, client helper thread. And this guy will take in a integer array called the file array. And we'll set this dot the file array equal to the file array. All right, so this is what this abstract class is. We cannot create an instance of this abstract class, but we're going to use it for our inheritance model. So I'm going to make this guy extend thread. So client helper thread extends thread. Our byte request thread extends client helper thread. Okay, and we need to add a constructor here for this guy. Kind of broke a naming convention here by starting my class name with a lowercase letter, but we're rebels. Okay, so this guy is going to take in an integer array called the file array. And we're going to ask our parent to deal with that. Go ahead and set that dude. I'm actually going to steal this here for a second. All right, so our byte request thread actually extends our client helper thread, which is an abstract class. Abstract classes only exist to support the inheritance model, to allow us to use inheritance to build it up. And the reason we did the client helper thread is because both of our fill thread and request threads both need to operate on this file array. One is filling it with stuff, the other one is sending stuff out of it. So they both need to operate with it. So I kind of used this simple example as a practical way of showing abstract classes, if that makes sense. You wouldn't be wasting that many lines of code to just write it in two separate classes yourself. So we did the byte request already? Yep. So now we'll go to the file fill thread. This guy also extends client helper thread. And we'll write the constructor for this guy. So this is file fill. We're rebellious on that one too. Okay, so now both of these guys have access to the protected file array that's associated with this guy. Okay, now both of our threads here need to have a public void run method associated with them. And we can go ahead and move this comment in here if we'd like, because that's really where the magic's going to happen. So this guy's going to constantly listen for a request from the server for a certain byte and responds to that byte. So as soon as we hear constantly, we could say while true if we want. Okay, something's going to kill off this client and probably kill this guy off. But for right now, we'll just say while true. We'll stop there for a second. Yeah, I just have a feeling you guys might have a programming assignment. No reason, but except for I told you you would last class.
Gotta get it in.
And that you're the one
Gotta
that's
get it
gonna
in
be
this
assigning
week.
it.
What's up?
And that you're the one that's going to be assigning it.
Yeah, I don't make those decisions very early usually. Sometimes we just got to see where we get in class. Okay, so this guy's also going to have a public void run. And so this method, this guy constantly tries to fill his byte array. Okay, so he wants to keep doing something as long as he hasn't received all the bytes. That make sense? As long as he hasn't received all the bytes. Okay, now, well, let's go back here then. We go to, we have too many files. Let's get rid, I'm going to close driver, Response thread's fine. Okay. So here's our get file. This is client communication protocol. So here's our get file and our share file stuff. So when we're somebody who's sharing a file, so we're that original. In our example here, we're Tim. Okay, Tim is never going to make a request, so he doesn't need to spawn off a thread for trying to fill his array, because his array is filled, correct? But Tim does need to create a new, just for the sake of argument here, I'm going to make these global, even though I don't think you actually need access to them. So we're going to have a private file fill thread, FFT, and a private byte request thread, BRT. Haha. Get it? You always have to be careful with that your shorthand for these doesn't represent something inappropriate. All right, so FFT, BRT.
You're gonna have to put D to F in there somewhere.
Somewhere, okay. So this is in share. So in this case,
Still thinking that Apple Watch app is.
we're going to say we only need to spawn a byte request thread, since we have all of the bytes already. Okay, so we're going to have that guy is going to be a new byte request thread, which requires us to pass this dot the file bytes to it as a parameter.
What method is that in again?
This is in the share file. So this is Tim. Tim came in as a client, said I'm sharing, so he's the original. So he uploads his file into a local buffer, so he has all the bytes already. But he will play a role in the network where somebody could request bytes from him. Certainly the first people who come in are going to be definitely requesting bytes from him. Okay? And then we're going to go ahead and tell this guy to start. Okay, so he only creates this guy. Now on the flip side, if we are the client, I'm sorry, if we are the get client, that means we need to spawn both a byte request and a fill, or in a file fill thread, since we are participating in sharing the portion of the file we have, and we want to fill in the rest of the file we do not have. Make sense? So we need both of those threads going. So we'll instantiate our BRT, byte request thread, tell it to start, and then we're also going to instantiate our file fill thread. And tell that guy to start. Okay? Makes sense? So on our picture over here, what we just did is we spawned both of these threads for these guys. Tim, though, only spawned one of them. Okay, so maybe the blue threads here are the request, the byte request threads, and these guys are the file fill threads. Okay, so this thread's constantly going to be going through, finding out what bytes he needs, asking the server for those bytes, and then the server's going to figure out who has those bytes, and ultimately request the byte from another client's byte request thread and then send the byte back to this client's file request thread. Does that make sense? Okay. So that's all I'm going to show you on the client communication side of things right now. I'm going to close that. That's our connected client. Here's our response thread. So here we're on the server. This is the response thread on the server. So the response thread on the server, if it's sharing, if the client that connected is the share client, meaning it's Tim. Okay? In this particular case, the server needs to possibly be able to send requests to Tim for communication. Right? It's saying, Tim, I need byte 7. Tim, I need byte 14. So on and so forth. I need byte 69, of course. All right, so in any case here, we're going to say we need to request bytes from our connected client that other connected clients need. Okay? So we need to request bytes from our connected client that other connected clients need. So we need to write code here. I'll steal this comment, so I'll kind of give you a little bit of a Google Maps approach to, so let me go back over here to file fill thread, write code here. Let's go to byte request thread, write code here. Okay, so that's what we'll do in this portion of it for our response thread for share. If we're in getting mode, okay, we're waiting for client requests. So, but there's kind of two sides here. We have clients who are requesting bytes, and then also some of these guys are clients who have bytes. And remember, last time, go to our server, driver. In our driver for our server, we were keeping track of who's busy and who's not busy. Right? So whenever somebody first connects, we create the connected client, we add them to our global list of all the clients, and then we also add them to the not busy clients. That is, that person's not currently serving a byte to somebody. Okay? Then we create a response thread, create our and then start it. And we say they're connected, and then we go back and listen for the phone to ring again. Okay, but we have a way to communicate with that guy. So what you're going to have to write here in fact, I might even do okay, this is waiting for a client to request a byte. So we receive which byte they want. We go through all of our connected clients that are in the not busy clients. If it's not us and the client has the byte, then we're going to share the byte with the guy who asked. So I'll say write code here. Now the reality is, and I might give you a hint here since we have 1 minute left, I wonder if you have to really differentiate between, after you've done the initial setup, between a share and a get client. Because the clients themselves are going to dictate what they expect. Even though Tim is the share client, he's never going to ask for bytes. It doesn't make any sense because he has all the bytes already, right? The get clients, though, are going to request bytes. So what you're going to need to do is you're going to have to set up that mechanism here on the server to constantly check to see if these guys have something. So you're going to go to Tim. Well, you'll probably skip Tim because he doesn't actually, his input stream, you can check, but his input stream is not going to have a request on it because Tim doesn't need anything. Then we're going to go to Abe and say, does he need anything? If yes, find out who has it, connect the dots. Then go to Mike. So there's just going back and forth through the entire list of clients, seeing who needs stuff. That makes sense? So you're going to have a loop that just keeps going through forever, potentially as long as we have connected clients, and just keeps taking requests and fulfilling requests. And we fulfill requests by sending a communication channel to the output stream of a connected client.
Kid in the sweatshop.
Make sense? All right, so I'll upload all these files to GitHub, provide you the links. So for next class, what you need to have working is all the clients need to be receiving bytes and also sharing bytes with other clients. And what we should have is as many clients as we have connected should get the file. So it's actually a finished server. Okay, and that's due on Tuesday. Should not be too difficult, but definitely draw pictures. Isn't it? What's today? Friday. It's due Monday. Due Monday. Shouldn't be too bad. Just draw pictures. All right, I'll see everybody on Monday.
Am I gonna have time now to come